Hello everyone, today I'll be going through the third worksheet for Year 12 Mathematics 3-4. All right, cool, let's start. So first of all, I just scroll through all my solutions. All right, that's all. For the first question, we use our log laws. So we know that this 2 here can be moved to the back to make 2x squared. And then because when we have two logs with same base minus each other, it's the same as them dividing. And then that is equal to log e2. We cancel the log on both sides. We move the 3 minus x to this side. We get the quadratic. We factorize it. And here we'll get two solutions for x, but keep in mind there's a domain restriction, and that's why x must be 1. The next question, we sub u as e of x. So instead of having this equation here, we have this equation. So again, it will be another quadratic. We factorize it. But keep in mind here, u equals to 5/3 is the only valid solution, because since u is equal to e of x, -2 is not a valid option here because this part is bigger than 0 essentially. And that's why u equals to 5/3. That means e of to the power of x is 5/3. X is equal to log e of 5/3. For question 3, f of g of x, all we have to do is replace the x here with g of x, so we just get square root of x squared minus 1. Next, we look at the domain and range. So we look at that, we see that the domain of g, which is the inner function of h of x, is all real numbers, and that will produce a range of 0 to infinity, and so this entire part is allowed in here, and essentially that's why we have the domain of h of x equal to real numbers. And because the input value from here is 0 to infinity, the smallest value f of x can output is 1, right? So that's why the range of h will just be from 1 to infinity. Yep, so next question, we're looking at some transformations. This is what h of x is. This is what, well, I call this h dash of x is kind of just like indicate the new version of h of x, which is equal to this right here. Keep in mind, we can make 4x squared into bracket 2x squared, and then we can do some equations. So we know the old x is equal to 2 times the new x, divide the 2 on here, so we know that x over 2 is equal to new x. That means that it's just a dilation factor of a half from the y-axis. If anyone's confused about this old x, new x, old y, new y notation, please let me know, and I can provide some help with that. So question 4. Again, for h of x, we just replace every single x in f of x, which is in this case just this x here with g of x, which gives us log e of x squared plus 1. Now we look at the domain and the range of h. So we know that domain for the inner function g is real, and the range for g is from 1 to infinity, and this set of values is allowed in f. In other words, the domain of h will just be real numbers, and with this set of values into f, we'll get a range from 0 to infinity, and that's the range of h, basically. The next one is just a bit, it's kind of just, writing what h of x is out, writing what h of negative x is out. And because essentially these are the same thing, because negative x squared is still x squared, that's the same as 2 of log e of x squared plus 1, and we can make the 2 at the back, and that will become f of g of x squared, which is what the question's asking for. Next question, there's many ways to do this question. I just took the derivative, and so in other words, for this derivative to be 0, we know that x must be 0, and we sub that into the into h of x here to get y is equal to 0. So we know the point is 0, 0, and it's the way we can think about it as a local minimum is the graph itself, like the log graph goes up like that, and because it's negative values of x, squared will become the same value as positive. So the negative side is just a mirror of the positive side, and we can kind of see here it's a local minimum. But of course, we can also utilize the range, right? Because we see from range here, this is 0 to infinity. In other words, if it's infinity, that means we really don't, have any other stationary points because it's going up all the way to infinity. And because the derivative shows that there's only one stationary point, so that stationary point must be the local minimum, and that should be 0 essentially. Okay, the next question, we want to find the inverse function of log e of x squared plus 1. So we start from here, swap x and y, solve everything. We will get this plus minus. So usually the way I would like to check for inverse function, like which of the plus minus side it is, that I will just choose any point on the original function, which is k of x here. So for example, I just chose -1 log e2, and we know that because for inverse function, x1 and y is swapped, so the new coordinate must be log e2 and -1. And because of that, we reject the positive version because if we start log e2 here, we'll get 1, and we need a negative sign here to make it -1. And that's why so sorry, I made a mistake here, not f inverse of x, k inverse of x must be negative square root of e to the power of x minus 1. And finally, to get the domain and range, we just have to look at the domain and range of k and then reverse them essentially. For the domain of k, it already gave it to us. For the range, we already said that the local minimum is at 0, 0, and it goes all the way up to infinity. So that must be the range. And we swap them around to get the domain and range for k inverse. So I should have wrote inverse here. Yeah, and that should be every single question. If there's any other questions regarding this worksheet, please let me know. And yeah, see you all next week.